In this video, you will learn how to solve equations with radicals and check for extraneous solutions. So we'll look at equations that have roots in the problem. Now, to clear a root, we can raise both sides to an exponent. To clear a square root, we can raise both sides to the second power. Say, for example, we have square root of x here on the left, and on the right, we have square root of 2. We can just raise both sides to the power of 2 to get rid of the square root. Then we have x equals 2. Now, to clear a cubed root, we can raise both sides to a third power. So let's say we're given cube root of x and cube root of 2. We can just raise both sides to the power of 3. Then we get x equals 2. There is one catch to solving a problem with roots in it. Sometimes we end up with solutions that do not actually work in the equations. This will only happen if the index on the root is even, and it will not happen all the time. So for these problems, it will be required that we check our answer in the original problem. If a value does not work, it is called an extraneous solution, and it will not be included in the final solution. So you take note that when solving a radical problem with an even index or even root, we have to check the answers. Now let's solve some sample problems here. Let's say we're given square root of 7x plus 2 equals 4. Now let's solve for the solution to this problem, or let's find the value of x. Let's take a look at or check the index here. The index is even since this is a square root, so we have to check our answers. Now let's solve this first by squaring both sides of the equation, or raising both sides of the equation to the power of 2. And then we simplify the exponents. So this would become square root of 7x plus 2 squared is just equal to 7x plus 2, then equals 4 squared. Then we simplify this. This would become 7x plus 2 equals 4 squared is 16. We subtract 2 from both sides to get rid of the 2 here. So we can simply solve for the value of x, and we have 16 minus 2 is 14. Then we divide both sides by 7, and we get the value of x, which is 14 over 7, or just simply equal to 2. Alright, so we got the value of x, which is 2. Since the index here is even and is equal to 2, we need to check the answer in the original problem, which is we need to plug in this value to the original equation. So that would be square root of 7x plus 2 equals 4. Then we substitute 2 to x plus 2 equals 4. We have to check if the right side of the equation is equal to the left side of the equation. If the right side of the equation is equal to the left side of the equation when plugging in the value of x that we just computed, then that means that value of x is a solution to the original problem. Alright, so this is square root of 14 plus 2 equals 4, and this is just square root of 16 equals 4. Square root of 16 is 4. Alright, so both sides here are equal, so it is true and it works. Therefore, x equals 2 is the solution to the given problem. Now let's solve another problem. Now what if we're given this one, cube root of x minus 1 equals negative 4. All right, this is cube root. That means the index is equal to 3, which is not an even number. So we have an odd index, which means that we don't need to check the answer. We just simply solve for the value of x. Now to solve this, to get rid of the cube root, we raise both sides to the power of 3, or we cube both sides and then we simplify the exponents. So cube root of x minus 1 to the power of 3, this is just equal to x minus 1. Then we have negative 4 cube. Then x minus 1 equals negative 4 cube is negative 4 cube is just equal to negative 4 times negative 4 times negative 4. Negative 4 times negative 4 is positive 16. Then positive 16 times negative 4 is negative 64. Then we further simplify this by adding 1 to both sides to solve for the value of x. Then we have negative 64 plus 1. This would give us negative 63. Therefore, the solution to this problem is negative 63. How about if we're given this problem? Fourth root of 3x plus 6 equals negative 3. Now let's check for the index. The index or the root is 4, and it is an even index. So that means we have to check the answers if the answers are a solution to the original problem. Now let's solve for the values of x first. To solve this, we just simply raise both sides to the power of 4 to get rid of the root. So fourth root of 3x plus 6 to the power of 4 is just equal to 3x plus 6 equals negative 3 to the 4th. And negative 3 to the 4th is simply just equal to negative 3 times negative 3 times negative 3 and times negative 3. And that would be positive 9 times negative 3 is negative 27 times negative 3, that is positive 81. And then we subtract 6 from both sides. This cancels out. Then we're left with 3x equals 81 minus 6, which is just equal to 75. Then we divide both sides by 3. Then we get the value of x, which is equal to 25. Now, since the index of the original problem is an even index, then we need to check the answer in the original problem. We just have to plug in the value of x to the original equation. So let's do that. So fourth root of 3x plus 6 equals negative 3. Then we plug in 25. So this is just fourth root of 3 times 25 plus 6 equals negative 3. And this is fourth root of 75 plus 6 equals negative 3. Let me delete this. Right. Okay. And then we have fourth root from here. Fourth root of 75 plus 6. So this is fourth root of 81 equals negative 3. Then we can write 81 as 3 to the 4th equals negative 3, and the fourth root of 3 to the 4th is equal to 3, which is not equal to negative 3. So that means this is this is false, and this is considered an extraneous solution. Therefore, x equals 25 is not a solution to this problem. Therefore, this problem has no solution. Now let's try solving other problems. Let's say we have two radicals, or we have another, aside from the radical, we have another variable on the other side. So if the radical is not alone on one side of the equation, we have to solve for the radical before we raise it to an exponent. Say, for example, we're given this problem, x plus square root of 4x plus 1 equals 5. We cannot directly raise this to the power of 2. And take note, we have a square root here, and that means we have an even index. And that also means that when we have already solved for the value of x, or the solution, we have to check the solution and plug it in back to the original problem, which is this one. All right, let's simplify this first before we raise this to an exponent. So we subtract both sides from both sides, x from both sides. Then this cancels out. Then we're left with square root of 4x plus 1 equals 5 minus x. And now we can square both sides. So the square of 4x plus 1 is just simply equal to 4x plus 1. Then we have 5 minus x squared, or we can simply write this as 5 minus x times 5 minus x. Then you can use the FOIL method for that. Then we have 4x plus 1. Using the FOIL method, we have 25. This one is equal to 25 minus 10x plus x squared. So you just have to multiply 5 times 5, negative x times 5 plus negative x times 5 times plus negative x times negative x. And then we get that one. Then we simplify, we group like terms. We can subtract both sides, or we can subtract 4x plus 1 or 4x plus 1 from both sides. So this would be minus 4x and then minus 1, minus 4x minus 1. Then we cancel out those terms. Then we're left with 0. This would be equal to 0. And we have 25 minus 1, that is 24. Negative 10x minus 4x is negative 14x plus x squared. Let me delete this. And now we have this equation here. This one. We have x squared minus 14x plus 24 equals 0. Now, how do we solve for the value of x, or values of x? We need to factor this. So we factor this one. We look for factors of 24 that when we multiply them, it would equal to positive 24. And when we add them, it would equal to negative 14. So we can use negative 12 and negative 2. So this would be x minus 12 times x minus 2. You can always check that by using the FOIL method, or just simply multiplying both of the expressions. And then we equate this. We set each factor equal to 0, so we equate x minus 12 to 0 as well as x minus 2. Then Okay, and this is equal to 12. X is equal to 12. We just have to add, you won't be confused, we add 12 to both sides, and this cancels out. Therefore, x here is equal to 12. And here we add 2 to both sides. This cancels out. And x is equal to 2. So the values of x would be, or the solution to this problem would be x equals 12 or x equals 2. And now we already have the two solutions to the given expression or problem. We need to check the answers if they are real solutions to the problem. So let's start with x minus 12. We plug in 12 here. So that would be 12 plus square root of 4 times 12 plus 1 equals 5. This is 12 plus 12 times 4 is 48. Plus 1 equals 5. This is 49 equals 5. And square root of 49 is 7. This is 19. And 19 is not equal to 5. So that means this is false. And x equals 12 here is an extraneous solution. So this is not a solution to the given problem. Now how about x equals 2? So let's check if x equals 2 is a solution to the problem. So that would be 2 plus, we plug in to the original problem, 2 plus square root of 4 times 2 plus 1 equals 5. 2 plus 4 times 2 is 8. 8 plus 1 is 9 equals 5. And square root of 9 is 3 equals 5. 5 equals 5. Therefore, x equals 2 here is the solution to the problem. And take note from the previous problem that we just solved. That one illustrates that as we solve, we could end up with an x squared term or a quadratic. So in this case, we remember to set the equation to 0 and solve by factoring. Then we will have to check both solutions if the index in the problem was even. And sometimes both values work, sometimes only one, and sometimes neither works. Now let's solve some more problems. How about if there is more than one square root in a problem? Then we will just have to clear the roots one at a time. So this means we must first isolate one of them before we square both sides. Say for example, we're given this problem, square root of 3x minus 8 minus square root of x equals 0. Now take note here that we're given a square root. So that means the index is even, which also means that we need to check our answers. Alright, so given this expression here, we cannot directly raise this to the power of 2. So all we have to do, we isolate first the root by adding a square root of x to both sides. Now this cancels out. Then this is square root of 3x minus 8 equals square root of x. And now we can square both sides. Alright, and this would give us 3x minus 8 equals x. Then we group like terms. We add 8 to both sides. Then we'll be left with 3x equals x plus 8. Then we subtract x from both sides. We get 3x minus x is 2x equals 8. And now we solve for the value of x. We just have to divide both sides by 2. Then our x would be equal to 8 divided by 2, or just simply equal to 4. Now that we already have the value for x, since the original problem has an even index, so that means we need to check our answer. We just have to plug in the value of x to the original equation and check if both sides are equal. Right? Our original equation is square root of 3x minus 8 minus square root of x equals 0. And then we plug in the value of x to that equation. So that would be 3 times 4 minus 8 minus square root of 4 equals 0. So this is square root of 12 minus 8 minus square root of 4 is 2 equals 0. And 12 minus 8 is square root of 4. Then this is 2 minus 2 equals 0. 0 equals 0. Alright, both sides are equal. So that means x equals 4 is a solution to the given problem. So take note that when there is more than one square root in the problem, after isolating one root and squaring both sides, we may still have a root remaining in the problem. So in this case, we will again isolate the term with the second root and square both sides. And when isolating, we will isolate the term with the square root, which means that the square root can be multiplied by a number after isolating. Let's say we're given this problem. Square root of 3x plus 9 minus square root of x plus 4 equals negative 1. Alright, let's check the index. The index is square root. That means it is even. And that also means that we will have to check the answers. Now to solve this, we must isolate the first root first. Okay, we can add square root of x plus 4 to both sides. This cancels out. Then we're left with square root of 3x plus 9 equals negative 1 plus square root of x plus 4. Or we can just simply write that as square root of x plus 4 minus 1. And now we can square both sides to get rid of the square root. So this would be 3x plus 9. And this one is just equal to square root of x plus 4 minus 1 times square root of x plus 4 minus 1. Right, you just have to FOIL that. Then we get x plus 4 minus 2 square root of x plus 4 plus 1. And then we combine like terms. We can combine 3x and x, then 9, 4, and 1. So this would become 3x plus 9. We transpose x to the left, that would become negative x. Then 4 to the left, that would become negative 4. Then 1 to the left, that would be minus 1. Then we're left with negative 2 square root of x plus 4 on the right side. And then we simplify this. 3x minus x, that is just 2x. Then 9 minus 4 is 5. 5 minus 1 is 4. That is equal to negative 2 square root of x plus 4. Now take note here that we still have a square root on the right side. So what we're gonna do, we square both sides of the equation again. So this would be 2x plus 4 squared, which is just equal to 2x plus 4 times 2x plus 4. You FOIL that, and we get 4x squared plus 16x plus 16. And this one, negative 2 squared is 4. Square root of x plus 4 to the power of 2 or squared. This is just x plus 4. Then we further simplify that. Let me delete this. So we have 4x squared. Let's just copy that here. 16x plus 16 equals 4 times x plus 4. So we distribute 4 to x plus 4 here. 4 times x is 4x plus 4 times 4 is 16. And then we combine like terms. We can transpose 4x plus 16 to the left. This would become 4x squared plus 16x plus 16. We transpose 4x here. This would become negative 4x. Then the positive 16, transpose that to the left, it will become negative 16 equals 0. And then we combine like terms. So we can combine 16x and negative 4x. We just have to copy 4x squared. Then 16x minus 4x is equal to 12. This is 12. X, then 16 minus 16 is 0 equals 0. And now we're left with only 4x squared plus 12. X equals 0. Alright, so how are we going to solve for x here? So we need to factor out 4x here. This is a common factor. So 4x, what will be left in the parentheses would be x plus 3 equals 0. And then we equate the factors to 0. That would be 4x equals 0. We divide both sides by 4, then x equals 0. Or x plus 3 equals 0. Then we subtract 3 from both sides. Therefore, x is equal to negative. Now, since the root here is even, and we have an even index, so that means we need to check our answers. We got two values for x, which are 0 and x equals negative 3. Then we just have to check if there are extraneous solutions. We just have to plug in the two values to the original equation, right, to check if they are solutions to the equation. So first 0, we plug in 0 here. Square root of 3 times 0 plus 9 minus square root of 0 plus 4 equals negative 1. So this is square root of 9 minus square root of 4 equals negative 1. This is 3 minus 2 equals negative 1. This is just 1, which is not equal to negative 1. So this is false. That means x equals 0 is an extraneous solution and it's not a solution to the problem. How about x equals negative 3? So let's plug in negative 3 to the problem. That would be square root of 3 times negative 3 plus 9 minus square root of negative 3 plus 4 equals negative 1. So this is negative 9 plus 9 minus square root of 1 equals negative 1. Negative 9 plus 9 is 0. So that would be square root of 0. Minus square root of 1 is 1 equals negative 1. So 0 minus 1 equals negative 1. Negative 1 is equal to negative 1. And that is true. Therefore, x equals negative 3 here is a solution to the given problem.